In this lesson, we are going to create a very basic AI that is going to try to decide based on scores which is the best column to drop a piece in. The first thing we are going to need is a function that will let us know all of the possible columns the computer can play in. So in our connect4.js file, let's create a new function. I'm going to put it right below above the isValidColumn function. So we say export function and let's call it getValidColumns. For this we are going to need the board, and we are going to create a variable here that is going to store all of the column indexes in which we can drop a piece in. So let's call it valid columns. This will be an array which is going to be empty by default. Then we can iterate over all of the columns in the board with for column equals 0, column less than column count, column plus plus. Now we can use the isValidColumn function down here to determine if this column is valid. So we can say if, and let's leave a space here too, if isValidColumn, and here we pass the board and the current column, and if this returns true, that means we can play on that column. So we add it to the list of valid columns. Valid columns, push column. And finally, we return valid columns. Save that. And now we can go back to our component. And in the methods part, we can add a new method. And I'm going to add it. Let's add it here, right before take turn. And let's call it select best column. Don't forget the comma at the end. And first of all, we are going to get all of the valid columns with the function that we just created. So valid columns equals to connect4 get valid columns and pass the board, this board. And did we call it columns or column? It should be columns. Let me check. Good thing I checked. It's get valid columns with an S. All right, back to our component. Now, as I said before, this is going to be based on scores. So the computer is going to drop a piece in each column of the board and evaluate what is the score that we get from that move. And at the end, it is going to select the column with the highest score. So first of all, we are going to need the highest score variable. So let highest score, and we are going to set this to a very low number to make sure that we will select a column at the end. So let's say minus 1000, for example. Now we need a column variable, which will be the column that we will end up selecting, but we need to initialize it first. So let's say let column, and we are going to select a random column from the valid columns array. To do that, we do math.floor, and here inside the math.floor function we call math.random times valid columns dot length. And what this will do is return a random number in the range of 0 and the length of the valid columns array. Now what we need to do is to iterate over all of the valid columns and get the next open row so that we can put a piece in there. So we are going to do for I equals 0, I less than valid columns dot length, I plus plus, and here we are going to get that column in that specific index that we're looking at now. So let's say let new column, and we get that from the valid columns array. So valid columns sub index I. Now we can figure out the row. So we say let row equals connect for get open row, and we pass the board and new column. Now here we need to drop a piece in the board, but we are not going to drop it in the actual board. We are going to create a copy of the board so that we can drop a piece in it and then evaluate the score and then move on to the next column and do the same. So I'm going to write the code first and then I'm going to create the function later. Let's say let board copy equals to connect for copy board, and we are going to pass the current board. Let's go and write this function right away. Let's go to connect4.js and let's add that function next to create board up here. So right after that, let's say export function copy board. We will take in a board. And the way we do this is using JavaScript's spread operator. Let me show you. First, we create a board copy of all of the rows. So let board copy equals an array, and in here we use 3 dots, which is the spread operator in JavaScript, and after it we used board. Here we are effectively copying all of the rows of the board, but we still have to copy the columns. We can do that by saying board for each, and this will take a callback function, and the parameters for that will be the actual row array and the index that we are going to call row index. And in here we are going to do board copy at the row index is equal to a new array with the spread operator, and we use the row that we have from the current iteration. So this effectively gives us a copy of the board with a different memory allocation so that when we modify it, the original board will stay intact. Now we just have to return board copy. Okay, let's save this and go back to our component. Now we can actually drop a piece on that board copy. So we can say connect for drop piece board copy row new column, and we drop a piece for the player 2, which is the AI, and in this case we decided that it will always be yellow. So this yellow. After we do this, now we have to evaluate what is the score of the board at the current state, right after the AI drops a piece in that column. For that, we are going to create a function that will take a board and return a score. But first, I'm going to write the logic here, and we are going to implement that function in just a minute. So let's say let new score equals connect for, and let's call this function board score, and this will take a board. In this case is going to be the board copy. Right after we get this new score, we can decide if that new score is higher than the current highest score. So if new score is higher than or greater than highest score, then we make the highest score equals to score, or actually new score. And also we make the column equal to the new column. This is ultimately what we are going to return. So right after the end of the for loop, we say return column. Now all we need to do is to implement this board score function. So back to the connect4.js, and right next to copy board, let's say export function score board. This will take a board, and let's start by initializing the score with 0, and we are going to do this in stages. First of all, we are going to score the center column of the board, because dropping a piece in the center column should have a high score, and therefore the machine or the computer should go first for that center column when making a move, if possible. So let's say let center column array, and actually let's add a comment here, score center column. This will be empty for now. Now we need the index for the center column, so center column, and we could easily say 3, but that to me is a magic number. So instead I'm just going to say math floor column count divided by 2. So that way, if for some reason you want to make a board with more than 6 columns, this will still give you the center column of that board. So what I want to do here is to go through all of the center column and add all of those pieces into a separate array, which is the center column array. So let's do that. For row, actually let row equals 0, row less than row count, row plus plus, and here we simply say center column array dot push, and we pass the board at the location of the current row and the center column. Now what I need to do is, from that center column array, I need to count how many yellow pieces there are, and for every yellow piece I will increase the score. Now, as far as I know, JavaScript doesn't have a built-in function that will let me count the number of specific items inside an array. So let's create a small utility function that will receive 2 parameters, an array and a value, and will return the number of times that value is seen on the array. And let's do it at the top of the file, since we don't need to export this function. It's going to be local to our file. We can say function, and let's call it count. We will receive an input array and an item, and here we say const, since this value is not going to change, map equals input array reduce, and the reduce function will take in a callback that takes 2 parameters. The first one is the accumulator value, or the previous value, which is going to be preserved on each iteration. Let's call it ACC, and then the key, which is going to be the key of the current iteration. So in this function, what we are going to do is simply say accumulator, or ACC, dot set, and I should clarify that ACC is going to be a map, not an array. The difference between a map and an array is that every item in a map is unique. Think of it as an associative array, and the map class in JavaScript has a set function which will allow us to set a new key in the map. And this will take the key and also the value as the second parameter. So for the key, we use the current key in the iteration. And for the value, we want to have a count of how many times that key has been seen in the input array. We can do that by open and closing parentheses. And here we say acc.get key, and this will effectively fetch that key in the map if it is available, or will return undefined if the key has not been found. So in the case that the key has not been set, we say pipe, which is OR, and then 0. So what we are saying here is either get us that key in the map or return 0. And right outside that parenthesis, we do +1. Now, this whole thing from here, from this second to last parenthesis up to here, is the callback function that we pass to reduce. But reduce also takes a second parameter, which is the default value for this accumulator variable. So right before the last parenthesis, we do comma new map. So the first iteration of this callback will have the ACC variable set to an empty map. And from there on, every time we iterate over a key, we are going to set that key with either 0, +1, or whatever value there was for that key. If that key, for example, has been seen once, then this will return 1, and then add 1 to that. So let's say, for example, the input array was something like this: 0, 0, 0, 2, 2, and 1. If you look at this from this side, that means that this column had a red piece at the bottom, then 2 yellow pieces, and then 3 empty spaces. Right after we call this line, map will look something like this. We will have the key 0 with the value of 3, which is how many times we saw that in the input array. Then the key 2 with a value of 2, because that's how many times we saw that in the input array. And finally, the key 1 with a value of 1. So all we have to do now is to return map.get and the item that we are interested in. So item. And next to it, we do pipe 0, just in case that item is not present in the map. Okay, now we can go back to our scoreboard function. And down here, we can count how many yellow pieces we have in the center column array. So let center pieces equal to count center column array. And do we have a constant value for the yellow pieces? We don't. We should have one here, I think. Maybe let's add a const up here. Let's say yellow, which is equal to 2. And since we're doing this, let's add the red as well, which is 1. And since we have them here, we should also use them in the component, but let's do that in just a second. For now, we have yellow here, and we can use that in the count function here. So yellow. And for every piece that we find in the center column array, we are going to add to the score. Let's say score plus equals center pieces, and let's say times, I don't know, 6, for example. Okay, we have the centerpiece column figured out. Now it's time to score the rows. Let's start with the rows. The idea here is that for each row, we are going to split that row into sections of 4. And then we are going to score those sections of 4 based on how many yellow pieces that section has. The more pieces, the higher the score. So let's say score rows. And here we can do board for each row. And in here, we are only going to check the sections where we can actually create a connect for. So let's say for column let column equals 0, column less than column count -3, column plus plus. Now to get a section of 4 pieces in that column, or from that column and row position, we do let section equals row slice column and column plus 4. Now we need to know what's the score for that section, and that code looks something like this. Score plus equals get score, and we are going to implement that function in just a second, and this will receive the current section. Okay, now we implement this function. Let's create that right above here. I don't think we have to export this one, so let's do this function up at the top, right below the count, just to keep order. So function get score section. Let's initialize the score at 0 first. And now we can make use of this count function up here. For example, if count section yellow equals to 4, that means that after we drop the piece in this hypothetical column, we actually have a connect for. So we need to give this section a very high score, meaning that the computer will definitely choose this column. So let's say score plus equals something high, let's say 100. Now let's say if count section yellow equals 3 and count section, and we also need to have a constant. We have one for yellow and one for red. We also need one for the empty space. So let's add one here. Const empty equals 0. And now we can use that here. Count section empty equals 1. That means that after we drop the piece in this column, we have a connect 3, which should give us a relatively high score, meaning that we are closer to a connect 4. So let's say score plus equals, I don't know, 10 maybe. Now let's do a connect 2. So I'm gonna copy this if here, paste it down here, and we are going to count for 2 yellow pieces and 3 empty spaces, actually 2 empty spaces. And for each one of those, we are going to add 5 to the score. Now we are going to do one last check to see if after we drop a piece, the opposing player has a possibility of a connect 4. We do this, I think we can just copy this if right here, paste it down here. And instead of yellow, we use red. So what we're going to do here is to subtract from the score a big chunk so that the computer will not select this column, because obviously this column is not a good decision. So I hope that makes sense. We're going to do minus equals, let's say 80. Okay, now I think we should just return the score. Now let's go back to the scoreboard, and here we can move on to the columns. Score columns. To do this, we are going to extract all of the columns into its own array. So let's do a for let column equals 0, column less than column count, column plus plus. This way we are going to iterate over all of the columns in the board. Now let's initialize the column array, and we are going to do this for each column. So column array equals empty array. Now to add items to the column array, we are going to start counting from the bottom row up and start filling up the column array with all of the entries in each row. To do that, we do a for, and let's add a space here, just for convention. For row, actually let row equals row count minus 1, row greater than 0, row minus minus. And actually this is greater than or equal than 0. In here we just have to add items to the column array with column array dot push, and what we are going to push is board. I think we call it board, right? Yep, board. Add row and column, and that's it. Okay, this for here will just give us one array with the entire column, looking at it from the bottom row and going up. Now we have to iterate over that array, that column array, and we are going to do the same that we did here, where we are going to slice up that array into sections of 4. So for that we are going to do another for, and this time we are going to use row, let row equals 0. We are going to start at 0 because now we can move from 0 up to row count minus 3, which will be the last place where we can actually have a connection of 4 pieces. So row equals 0, row less than row count minus 3, row plus plus. Now we create a section with let section equals column array dot slice, starting from row and going up to row plus 4. Now we just get a score for that section with score plus equals get score section. Okay, so now we have the score for all of the columns. We add that to the score, and also for the rows. Now we can move on to scoring the upward diagonals. So score upward diagonals. And just a little detail before we move forward, I just noticed that I have an error in the naming of this scoreboard convention, because actually in the component I named that board score, so I have to name it the same way inside connect4.js, like that. Okay, with that out of the way, let's move on to the diagonals. And the approach is going to be pretty much the same. We are going to put each diagonal into its own array, slice it up in sections of 4, and then get a score for each section. So let's start with a for loop to count the rows from the bottom up, and we should be used to do this by now. So it's let row equals row count minus 1, row greater than or equal than 0, row minus minus. Now, since we are going upward in a diagonal, we also have to count the columns. So for let column equals 0, column less than column count minus 3, and then column plus plus. So with this, we are going to iterate over all of the upward diagonals. Actually, this might be even easier because I don't think we have to put the upward diagonal on its own array. I think we can just slice the section right now and then get a score right away. Let's see. I'm going to initialize the section array as empty, and then I'm going to do another for loop to fill up that section, which is going to go from, let's just say, I equals 0, I less than 4, I plus plus, and here we just have to do section dot push, and we are going to push board, the position of the board, at row minus I and column plus I, which basically is just counting up in the rows and counting right on the columns. But the first time we go in is not going to, it's going to be 0, so it's just going to add row and column, then row and column minus 1 and plus 1, etc. Okay, now that we have the section filled up, we just have to get the score. So score plus equals get score section. All right, now let's move on to the downward diagonals. So score downward diagonals, and this is going to be kind of similar to this one up here, except that we still are going to count the columns from left to right, but we are going to count the rows from top to bottom. In fact, I think we can just copy this whole section right here, paste it here, and then row is going to start at 0, row less than row count minus 3, because again, we don't have to count all the way down, and lastly, row plus plus. Column is going to stay the same. We are going left to right on the columns, initialize the section array, and in this for loop, instead of doing row minus I, we just have to do minus plus I. And that, I think that's it. Okay. So with this, we kind of have like a very simple AI, which is going to try to determine, based on the final score, after going through all of the board, which is the next best column to play in. But we currently don't have anything to test this out, so let's go and add that into our component. Let's save this first and foremost, and then in our component, right after take turn, I'm going to add another method called AI turn. And in this method, the first thing we're going to do is to select the best column to play in. So let column equals this select best column. And after we have the best column to play in, we need to have, or we need to get the row, the next open row in that column to drop a piece. So let row equals connect for get open row. Get open row right here. And we have to pass the board and the column. This board and column. And now that we have the row and the column, we just have to drop a piece in the board. So connect for drop piece, and we pass the board, the row, the column, and the color, which is always going to be yellow since the AI is always going to be player number 2. So this yellow. And now we just have to check if after dropping that piece, the player 2 won. So we have to do if connect for is winning move, and we pass the board and the color is yellow. And if that is true, then we just have to set the game over variable to true. So this game over equals true. Otherwise, we just have to switch the turn to player 1. So else, actually not here, else, and we can just copy these 2 lines from here to here. Okay, now that we have the AI turn method, now we have to actually implement it on the take turn method over here. And let me just remove this console log. We don't need that anymore. And right here on this else, after we drop a piece, and right after we switch turns, we just call this AI turn. Let's see if we can test this out. I'm going to switch to my terminal real quick, and if you don't have it already, let's start the development server with npm run serve, and let's navigate to this address right here in the browser. And let's see, I'm going to drop a piece in the center column, and it's not working. Why is that? Let me check the log. Column not defined. In connect4.js line 105. Let's go check that out real quick. Connect4 line 105. Oh, okay, yeah. I missed the let column in this for loop. So he thought I was referring to a variable, and that variable was not defined. Save that. And seems like it's complaining about something else now. Score is assigned a value but never used. Connect4.js line 53. Okay, I think I know what it is. I think I never returned the score variable in the board score method. Let me check. So board score, we have the score here, and we add to it on each of those 4s, but at the end I forgot to return the score. So return score. And yep, that fixed it. Now let's go to the browser again. I'm going to refresh, make this smaller, and let's see, I'm going to drop a piece in the center. What now? Let's see, property 3 of cannot read property 3 of undefined. That's weird. That's in connect4.js line 86. Let's see, line 86 right here is not reading either row or column. Let's see, row count -1. This is an upward okay. Yeah, this cannot go all the way up to 0, because if we are looking at an upward diagonal, we have to only reach row count -3. Make sure there are no errors, and then back to the browser and refresh. Okay, fingers crossed. I'm going to drop a piece in the center column, and there you go. Well, it's instant, but he did actually selected the center column. So let's see. I'm going to drop a piece here, and it's still selected the center column because we gave that a highest score. So let's block it right away. Still selecting the center column again. I'm going to drop a piece here, and it's still going for the center column. So let's see if I drop a piece here. It should try to block me. And it did. Okay. It's not that dumb. Okay, let's play here. But here's the problem. If I drop a piece here, the computer is trying to prioritize a connect 3. It's not going to know that I am about to do a connect 4 here. So if I drop a piece now, well, actually it did notice, but the problem is that I had two options, either to the left or to the right. So it did try to block me, but I am going to win anyway. So it's kind of smart, but not that smart. In fact, we can easily beat the computer if I just do this. Drop a piece here, then another one next to it, and I do the same here. Tries to block me on the right side, but then I win on the... Actually, it tried to block me on the left side, but I win on the right. Same thing if I go left this time. Blocks me on the right, but I win on the left. So as you can see, the AI is not perfect, and it's really easy to beat the AI in this mode. And that's why in the next video we are going to create an even better AI, one that it's really hard to beat. Not impossible, but really hard. But before I forget, let's go back to Connect4.js, and if you remember, we added a few constants up here, one for yellow, one for red, and one for empty. And I want to make use of these constants in the component file. So go back to the component, and in the data section, instead of using 1, 2, and 0 here, I can just say connect4.red, connect4.yellow, and connect4.empty. And that's it. So I'll see you in the next video where we are going to create a smart AI.